There's one more example in this lesson where you need to conduct a goodness of fit test. We're going to read the problem together. We're going to state the null hypothesis and the alternative hypothesis. And then we're going to talk about how to calculate the expected values. And then I'm going to stop the video. I'm going to let you finish the problem on your own. So let's start by reading the problem. We're going to be making notes as we go. A study indicates that the number of televisions that American families have is distributed as follows. On this table, we see that 10% of American families have 0 televisions, 16% of the American families have 1 television, 55% of the families have 2 televisions, 11% of the families have 3 televisions, and 8% of the American families have over 3 televisions. So notice, here we have 5 different categories. This is a qualitative variable because categories were made. For example, if a family owns 5 televisions, they're going to be in the category over 3. Because again, we have categories, this is a qualitative variable. This is a categorical variable. Here, we're also being told what percent of families land within each category. This percent is going to help us find the expected value. Let's just make a note to ourselves. We're going to just use these to find the expected value. So we're going to be coming back to this table when we're finding the expected value. Okay? So this is a known distribution. This is the distribution of American families. Now, a researcher believes the families in the far western United States are different than the US population as a whole. Okay, so here comes the challenger. The researcher went out and randomly selected 600 families in the far western United States. So that is going to be our sample size. We have the results from these 600 families on the table below. Here, we have the observed count for each category. So I'm just going to write observed values. And we see the observed values here on the right column, right? The left column is the categories. The right column is telling us the observed values for each of those categories. Remember, your observed values always come from the sample. They're given to you. We're going to use a level of significance equal to 0.05 to make a conclusion. Notice here, we're not directly being asked to conduct a goodness of fit test. How do we know that we need to conduct a goodness of fit test? Well, here we're comparing 2 distributions. We're wanting to know if the distribution of number of TVs owned by families in the Western United States is the same as the number of televisions that American families own. Right? So we're comparing 2 distributions. We're wondering if one distribution follows or fits the known distribution. So we're going to go ahead and run a goodness of fit test. The null hypothesis is going to state that our distribution follows the known distribution. Let's go ahead and use the context of the situation to write the null hypothesis. We're going to say the distribution of number of TVs owned by families in the Western United States, and we can say fits, follows, or is the same. I'm just going to say follows the distribution of number of TVs owned by American families. So again, notice I'm saying the data coming from families in the Western United States follows the distribution coming from all American families. Now, the alternative hypothesis is going to look the same. However, we're going to say that the distribution does not follow the distribution of number of TVs owned by American families. I'm just going to add does not follow. Now, you can also state this using mathematical symbols. I'm not going to take the time to do that. And the reason why is because with this type of test, it's better to have your null hypothesis and your alternative hypothesis written in words, because that is going to help you write a conclusion for the test. So now, let's talk about finding the test statistic. To find the test statistic, we need to find the expected number of families for each category. The sample size here is 600 families. So assuming that this data follows the distribution of number of TVs that American families own, how many would you expect out of those 600 families to say that they own 0 TVs? Okay. Well, we expect 10% of all families to say they own 0 TVs. So if I want to find the expected value, we're going to take the probability for this category, which is 0.10, that's equivalent to 10%, times the sample size. 0.10 times 600 is 60. Now, if 16% of the families are expected to land on the second category, where the number of TVs is 1, then the expected value for this category is 0.16 times 600. Okay? That is the probability for this category times the sample size. This is going to give us 96. Now for the third category, the probability is 55. So we're expecting to see 55% of the 600 families land in this category. To calculate the expected value, we're going to take 0.55 times 600. We get 330. Let's do one more together. The expected value for the fourth category is going to be 0.11 times 600, which is equal to 66. Out of those 600 families, how many are you expecting to see on the last category? We can compute the expected value by taking 0.08 times 600, which is equal to 48. Again, assuming that the data coming from those 600 families in the sample, we're expecting to see 60 under the first category, 96 under the second category, 330 under the third category, 66 under the fourth category, and 48 under the fifth category. Those are the expected values for each of the categories. I'm going to go down to the table that we have here below. This table is present here to help you calculate O minus E squared divided by E for each of the categories. Now you have the expected values. Okay? And let me just copy the expected values. We have 60, 96, 330, 66, and 48. You have the expected values for each of the categories. I'm going to let you do this on your own. Below this video, I'm going to ask you to enter the value for the test statistic. Below this video, I'm also going to ask you to enter the p-value for this test statistic. Then I'm going to ask you to make a decision. Are you rejecting the null hypothesis, or are you failing to reject the null hypothesis? Okay? And then at the end, I will go ahead and provide a conclusion. I encourage you to try to write the conclusion without looking at the answer. For your exams, you're going to be asked to write a conclusion on your own. Okay, so make sure to practice this. For this lesson, I'm giving you the answer so that you can try the daily assignment as many times as you want. So this is the end of our lesson. I encourage you to open the last warm-up homework assignment that we have for this class. And I encourage you to look at some of the problems where you have to conduct a goodness of fit test.